Hello students, today we are going to discuss the new chapter named Support Reactions. Let us see the introduction of the chapter. What is beam, what is support and what is load. Here you can see what is the meant by a beam in engineering. A beam is a structural element which is capable of withstanding transverse loads. Simply a beam transfers its applied load to the supports. Means beam is a horizontal member on which at various points loads are acting and this load is transferred to the supports. What is meant by a support? A support is an element which bears the weight of the beam and keep it upright. Simply, we can say that it is a thing which keeps the beam in equilibrium. So, support is like this under the beam, which carries the load over the beam and keep it upright without deformation. What is meant by a load? A load in this concept refers to the force acting on the structures. This is the reason this can be also called as structural loads. So structures means beams, frames, etc. And the forces acting on these structures are known as loads. Let us go ahead. What is the types of supports? There are mainly four types of supports based on concepts: fixed support, simple support, roller support and hinge support. Let us check one by one. What is fixed support? This support keeps the end of the beam fixed. As you can see in the figure, ends of the beam is fixed. One end of the beam is fixed over in this figure. It happens that both the ends of the beam can also be fixed. The beam ends resist to take any kind of translation or bending moment. In the below figure, we are going to see how this support will be. So this is the figure in which the beam, horizontal beam, is fixed at one end so that it resists this support resists the beam to from bending, clockwise bending. Okay, it happens that this beam can be fixed from both ends also. Let us go ahead. Simple support. Second one is simple support. In this type of support, the beam is allowed to rest freely on a support, as we can see in the below figure, and thereby we can observe that the beam is free to move in any direction and also to rotate about the supports. So this type of beam is supported at both ends. So this type of support is known as simple support, in which support are not permanently fixed, it is just resting at both the ends of the beam. Let us go ahead. Roller support. As you can see, suppose wheelchair, stretcher of the hospital, etc. are the examples of roller support. Roller support gives capability of movement to the respected beam. Connected to it may be along normal to the guides, or it can also rotate about the support, as we can see in the below figures. Simply, you can see for the simplified words, stretcher of the hospital, automobile cars, automobile vehicles under which the supports are always roller are known as roller support, which can provide the free movement of the beam. Free movement of the vehicle, free movement of the stretcher means free movement of the wheel. Okay, let us go ahead. Hinge support. As you can see, the door or the railway crossing, you can see these are the examples of hinge support. A hinge support restricts the movement of the beam in any directions, but it will allow the beam to rotate about the support just like a door, which is a best example of hinge support. So mainly these are the types of supports: fixed support, roller support, hinge support, simple supports. Okay, now let us moving ahead. These are the types of beams. There are mainly six types of beams: fixed beam, cantilever beams, beam with one end hinge and other end as roller, simply supported beams, overhanging beams and continuous beams. Let us check one by one. Okay, so this is the example of fixed beam in which the beam is fixed from both ends. A beam which is having fixed supports on both of its ends, it is named as fixed beams. And we can see some animated and real examples of this kind of beams and how they are restricting the movement of the beam. So as you can see in the figure, there are the original structures in which the beams or the components are fixed from both the ends are known as fixed beams. Cantilever beam. Cantilever beam means what? The beam or the structure is fixed at one end only. Then this type of beam is known as cantilever beam. So one end is free and one end is fixed. It is known as cantilever beam, as we can see some best examples of cantilever beam in the figure. See the structure in which the one end of the gallery is free and other end is fixed at the wall. So this type of beam is known as cantilever beam. Now beam with one end hinge and other end as roller. You can see this beam has one of its end hinge and the other side of the beam is supported with rollers. The load is acting at a distance A from the left support. This load is known as F. Length of the beam is L. This kind of beam are capable to withstand loads in any direction. Below we can see the conversational figure. So this is the beam with one end hinge and the other end roller. Simply supported beam. A beam with simple supports exactly at two ends of the beam, then it is called as simply supported beam. In the real world, people won't tend to design anything with simple supports, but one of the ancient monument was built up by this support. So you can see in the figure, this is the horizontal beam which is supported by several supports which are known as simple supports. Let us go ahead. Overhanging beams. Overhanging beams means what? As you can see in the figure, though there are two supports provided under the beam, then also some portion of the beams are left out from the support. This beam will also have supports, but one end or both ends of the beam will be having some extension after the support, as we can see in the figure below. So by this extension, these beams are known as overhanging beams. The support can be roller, simple or any other. Continuous beams means bridges. The most common example of the continuous beam is the bridge, under which several supports, more than 2-3 supports are present. This type of beams are known as continuous beams. Let us move ahead. There are several types of loads acting on the beam. Mainly three types of loads are acting on the beam. First one is point load or concentrated load. Second one is uniformly distributed load. This type of load is also known as UDL in short form. Third one is uniformly varying load. Let us check one by one. This is point load or concentrated load. As you can see in the figure, when you are hammering a nail on the wall, then you are continuously applying a load on a single point. So this type of load is concentrated at a definite point, then it is named as concentrated load or point load. We can see some best examples of point load in this figure. Let us move ahead for the second load, which is known as uniformly distributed load. A distributed load is a load which is spread on some length of the beam. You can see here it is 1000 mm length 1000 mm length of the beam is given. Thickness of the length is 10 mm and width of the beam is also 10 mm, on which continuously spreaded load is given. When the load is continuously spreaded on the beam, the unit will become Newton per meter. Means per meter length there is some amount of load like 1000 Newton is acting. A distributed load is load which is spread on the some length of the beam. The reason it is measured in intensity with unit is Newton per meter. If the intensity is constant along the length, then it is named as uniformly distributed load. You can see also in the figure, there is a truck carrying pipes of metals, pipes of RCC, etc. So this type of load of the pipes is continuously distributed on the entire truck. So this type of loads are known as uniformly distributed load. Let us discuss the last load. Last and third load is uniformly varying load. You can see two figures in the screen, that is left side support is A, right side support is B. One support is fixed or hinged or it may be any, and second support is roller. Now in the first figure the load is highest at point A, and then after continuously load is decreasing up to point B. While in the second figure, at both the ends load is 0, but moving from A to B, load is continuously increasing. At midpoint it becomes maximum, and at the end point again up to point B it is continuously decreasing and finally becomes 0. So this type of figures indicates the uniformly varying load. So what we have to do in this chapter, there are only three theories in this chapter. First one is types of beams, types of supports is second theory, and types of loads is the third theory. So you have to practice these three theories. In the next lecture we will start numericals based on the theories. In the numericals, what we have to do, we have to convert three loads into one load. Means point load is converted into point load. As it is point load, so no conversion is required. In the second case, UDL is to be converted into point load. Means UDL is to be drawn again in the simplified figure with the help of point load by help of some mathematical calculation. We will see in the next lecture. In the third case, UVL is also to be converted into point load. So with the help of mathematical formulas, these all loads are converted into point loads, and thereafter we will find support reactions. Means which support can carry how much load. Okay, if there are two supports under the beam, then first support will carry 1000 Newton load and second support will carry 2000 Newton load. So total load of 3000 Newton will be supported by two supports separately. So this type of sums, this type of numericals will be discussed in the next lecture. Till then, goodbye students.